salvate.
Yeah, it's okay. This topic is quite important one. You know why? The membrane usage is getting higher. Yeah? Even in the wastewater and water treatment, even though it costs a little bit higher, but the efficiency is so good. That's why membrane is getting popular. So somehow I like to let you know how the membrane made. So that's what I like to concentrate on. So yeah, this course you can actually learn how the membrane is produced commercially. Also, there are several different methods as well. Oh, this one doesn't know. What happened? So this is kind of the bullet point. Membrane filtration serves a vital role not only in making water safe for human use, but in chemical, biological, and industrial applications, removing cells, cell debris, and other contaminants. See, here, first one, particle filtration, micrometer size, 10 micrometer, then you can use in any kind of the screen, so you can also pre-filter some of the material. The Professor Mukhopadalit, he brought that's probably good for particle filtration. Somehow it works for the microfiltration area as well. Bacteria. So I don't know whether you notice or not. The red blood cell is quite big. Eh? The white blood cell is a little bit smaller than red blood cell, but the red blood cell is quite big. Bacteria and virus. So the ultrafiltration area is 0.01 to 0.1. Nanofiltration is 0.01 to 0.1. Reverse osmosis is 0.001. Then what about the filter media itself? If I want to use for reverse osmosis, then the pore size has to be less than 0.001. That's membrane area. Yeah? This kind of deputation, microfiltration, bacteria removal, and ultrafiltration, protein, virus, colorant. The end of this presentation, I asked to use the video. That video is going to be really interesting one. Ultrafiltration that is occurring in the kidney, in our body, kidney. So, the membrane, some of the membrane, the pore size is so small, so normally most of membrane we have to use cross flow membrane.
Some noise is coming. I want to adjust.
Okay.
Yes, yes.
Okay. Yeah. Yes. That. So when you talk about the membrane, you only use cross flow mechanism. Now, microfiltration remove the particle. Typical range is 0.025 to 10 micron. Ultrafiltration 0.001 to 0.05 micrometer. Reverse osmosis less than 0.001. Well, yesterday I heard that most of you already know osmosis, reverse RO. Who doesn't know about osmosis? Probably everybody knows about it. Huh? Anyone knows electrodialysis? This one is the membrane, a cation, anion membrane, cation membrane. So it's selective. You can filter out if the particle or anything that is charged. Now, I'm going into the membrane material itself. Polymeric membrane, polyether sulfone, PES. So good thermal, yes, the thermal is important one, PES. The last one, stress PTFE, of course. If thermal is concerned, this is a lot better than any other material. Polysulfone, polyvinylidene, PVDF. This is quite important material. However, this is a family of PFAR, like PTFE, which means forever chemical, forever. So that's currently the people are worrying about it. And polyamide, cellulose acetate. Cellulose acetate used in reverse osmosis. However, pore size has to be really, really small. In organic ceramic membrane, this is getting popular too. Alumina, zirconia, silica, titanium. Metal membrane, well, I don't know, it can go down to the ultra range, but certainly microfiltration, we can use metal. A composite membrane is multiple layer of the material. By the way, currently the media you see an innovative material, everything is multi-layer. Other advanced membrane, graphene oxide, carbon nanotube, and metal organic fragment. We're going to go one by one later on. This is what I'm going to cover. 5 minutes?
10 minutes. That's it.
Okay. Solvent cast method, air cast membrane. In fact, solvent cast method is most popular. It has been. And stretch membrane, it is getting popularity. For myself, this is the future membrane. I strongly believe so. See, I checked the internet, the rating of membrane. You know what is the number one? I checked several different websites and checked it. Stretch membrane number one. Yes. 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 Yes.
Polytetrafluoroethylene.
Uh, so I'm gonna go over one at a
So
time.
that is different. PPT is different. Polypropylene, polyethylene, but that can be very stronger, very strong. That is the difference because these are the other types of membrane category. Okay, PP, these are the other type of membrane category. So that is the commercially they are using.
What is the difference between media and membrane?
Huh?
What is the difference between media and membrane?
Say, say, saying yes. Media is broad terminology. It is filtration material. It's called media. Membrane is small area of filtration material.
Membrane is one of the media.
Yeah.
Crystal media is a broad. Like you can have the media by metal also. You can make the media by ceramic also. It is one of the terms.
You have to tell
5
me.
minutes.
Funny. Okay, here.
Membrane is only one-sided permeable.
It doesn't have to be.
One-sided?
Permeable
One-sided permeable means what?
means only the fluid can go from this side to this side, not from this side. That's possible, you know?
That depends on the direction of flow. Variability is the membrane.
Okay.
Membrane is
See,
used.
certain membranes are asymmetric membrane. So you'll have to maintain the like, as mentioned, that multi-layer membrane. So you'll have to put the direction properly. Suppose it is not a multi-layer, it is a singular layer, then that doesn't matter. Wherever from the flow, it can.
Ajay,
Yes.
are you trying to say about absorbing material
No,
or
no,
is it
sir, no,
filtration
sir.
material?
Just for example, if we talk about osmosis, then it restricts the flow from this side to this side, even the flow is from one side to another. But it cannot pass even without pressure. We are not applying pressure from this side to this side, but it still restricts the flow from other side.
Osmosis is different. Normally osmosis is without the application of pressure. Okay, it is depends on the
Density,
concentration. One will flow from one side to the another side. Whenever you are applying pressure of the higher concentration side, obviously it will work in the opposite manner. That is why the reverse osmosis came in picture. So nowadays the people are also going for forward osmosis. You are increasing deliberately the solute concentration, okay, and one side, so that the water can move from the pollutant side to the clean side.
One day, Professor Bajpayee had quoted that there is a difference between media and membrane. Membrane cannot be a media.
No, no, that is wrong. Media is everything. Media includes everything. Okay, that is wrong. Membrane, see, you cannot say that textile. You cannot say it as a textile media. That is one of. Textile media is the textile media which is made out of the textile media. Membrane is another category. It doesn't fall under the textile media. But you cannot say that it is not a media. It is also media, but it doesn't fall under the textile media. Textile media, just whatever the material I have shown you, that are all textile media. filament, spun yarn, or whatever.
But polymeric media cannot. We are manufacturing electrospinning nano. Can we say that is membrane?
Okay, then it is a, you can also talk it as that media also, textile media, because initially it is made, because it all depends on how it is being made. Suppose in some cases what the people do, making membrane, they make a sheet, simple sheet, without making the fiber. They simply make the sheet, they punch hole, okay, and then they expand it. Suppose if you are making process, manufacturing process is different, then it will be a, it cannot be termed as textile material. Because you are making a sheet, you are punching, because the geogrid and some of the geotextile application, you can punch the hole, and then basically it is expanded in both directions, so that you can produce the whole. So it will be purely by membrane, but if you are making the membrane by electrospinning, for example, then it will come to the textile category, because you are making process is fiber. First you are making the nanofiber, then from the nanofiber you are making the membrane. So membrane can be textile based, also it could be non-textile based. Both is possible. But polymeric membranes, I think we can consider it textile unless it is steel or the other ceramic. If it is simply a sheet like solvent cast method, and if you are preparing a sheet, okay, initially, okay, and it is not a fibrous matter, and you are punching hole and then you are extending, expanding it, then it will be purely a membrane category.
Okay, here, everyone talk about the aloe, but I don't know whether you pay attention to the media that pass through. The media is my concern. Aloe or osmosis. The media has to be, the pore size has to be really, really small one. Because you are talking about water molecules. Water molecule are going to pass through it, nothing else. So that is what we are talking about right now. That is membrane area. So this is quite popular membrane. PVDF membrane made out of this process. Most of the membrane made out of it. Well, it's a little bit older technology. But I don't know whether you notice or not. They use porogen. Porogen makes holes, hole structure. So you have to mix with the porogen. So the example of porogen is here. This is structure of the solvent casting. Polyether sulfone is gradient density one, but the PVDF really great, the structure-wise. So I like to stop here. Continue after the trip, plant trip.
Yes.
Rest of the membrane technology. This one, we already covered that one, solvent casting, but this is really popular one. And next one, and this is the example of solvent casting. Next one is air casting. It's almost same, but it's not solution, but still they use solution. But somehow,
The solution made of solution that is correct for
okay, it depends on the polymeric material. So PVDF PVDF is not really air casting membrane.
Solvent cast membrane, right?
Huh?
PVDF is for solvent cast membrane, right?
Well, it's not, well, I don't know, probably you see. Air casting. Cellulose ester, right by cellulose ester membrane are made out of the esterification cellulose, typically using acetate and nitric acid to produce cellulose acetate and cellulose nitrate derivative. These membranes are widely used in laboratory and industry application due to their excellent chemical comparability, high flow rate, and low protein binding properties. Okay, this is my key interest. Key interest. Yes. Stretched membrane. There are two different stretch. One is dry stretch, and second one is wet stretch. So dry stretch, you have to make the polymeric sheet first. For instance, high density polyethylene, then you have to extrude high density polyethylene through the extruder. And then you have to make really thin film and not like sheet. Yeah. And then the other important thing is, first you have to stretch machine direction only. We call it MDO, machine direction orienter. MDO, machine direction orienter. So you have to stretch machine direction first. Normally, when you stretch machine direction, you have to apply the heat. Yeah. So the heat temperature is quite sensitive. So whether it's polyethylene or polypropylene, polyethylene probably around 100 degrees C. And polypropylene is a little bit higher, maybe around 120 or so. So it's right before melting point. You have to choose the right temperature and stretch machine direction. Higher the machine direction stretch ratio, the better. So it takes some skill, because once you stretch the widthwise, it has to be uniform across the width. Otherwise, the product you're going to get is not really uniform. So normally, machine direction stretch is quite important. Then transverse direction stretch. So here the polymeric film, machine direction like that. In fact, I didn't bring the actual picture of it. It's actually several rolls. Several rolls. Go over the roll and roll. So it's not like go to the stretch like this. No, it's not. So you have to set the individual roll temperature precisely. So I should have brought some pictures. But anyway, probably number of rolls is about 6 of them. Go through six rolls. 1, 2 rolls, 3 rolls. Go over something like that. Not like this one. Not like this. This roll. the overall system, first you have extruder, and then you put the pellet, polyethylene pellet or polypropylene pellet into the hopper and extrude and make kind of thin, thick film first. And then you have to stretch. This one is not roll. Stretch as far as you can, and then make a little bit thin one, and then go through the MDO. MDO is machine direction oriented. Then we have to use so-called tenter. I'm going to show you later. Tenter. And then you can obtain the biaxial stretch film. That is I don't know why they call it the dry stretch, because polymeric material you have to melt and make the sheets or films, right? But they still call it dry stretch. Then what is wet stretch? When you make the PTFE stretching, EPTFE, expanded PTFE, then somehow you have to mix with some paste. So it's the isopal petroleum oil. You have to add it to it. So that kind of paste-like. The PTFE is really fine powder, fine powder. So from fine powder, somehow you have to make sheet. How you going to make sheet? Then you have to use some kind of oil. So isopar something. So oil. The other important thing is the raw material you have to store at the room temperature.
Room temperature.
No, lower than room temperature, because otherwise it crystallizes quickly. So storage, it has to be around less than 20. No. Important temperature is 19 degrees. 19 degrees is important. So it has to be lower than 19 degrees. Storage is same thing. The trouble is, if we got some material, raw material, PTFE material from, let's say, China, then during the shipping, the temperature going to go up more than 19 degrees, and then you have problem. So they have to put it in some cold box. Also, they have to control the temperature inside too. So the 19 degrees is critical. So they have to maintain less than 19 degrees. The putting with making paste-like material, and then we normally leave at the 19 degree, below 19 degree for 2 days. And then somehow you have to extrude out and make some sort of film. It's the same thing. After that, same thing. You're going through the MDO. That's why they use the wet stretch. They use some sort of solvent to make their paste. That's the difference. But EPTFE making that way. So wet stretch process is making expanded tetrafluoroethylene film. Here it is. This is actually TDO, not MDO. MDO has a lot of roles, but this one is TDO, stretching, coming out and stretching transverse direction like this. See, most important thing is this one, clip. Clip is quite important. Probably about 20 years ago, they did use the more than inch clip, but nowadays it's a lot less than inch clips. So it's the quality depending on the clip itself, right here. Clip. Bruckner is still making it, but price is high. So you don't understand. Film goes inside and stretch. Here, this one. A little bit of the gray area, that is film. This is the, I already show you this picture. Look at this. This is 5 micrometer. What do you think of the single fiber itself? Let's say this is 1 micron. What do you think of? It's about 10. Yeah, yes, yes, correct. This one is actually desirable. However, I don't know whether commercially we can stretch like this. Okay? This is highly stretched material. So normally what you see is something like this. That is actually commercially available EPTFA. What? Pore? Pore size is probably around 0.2 micrometer. Yes, pore size. I'm not sure though. Okay, this is this is commercially available. A dry stretched polypropylene extruded film. But quality-wise, it's a little bit issue, but it is available. But this one, the porosity is a lot. So normally EPTFA, the porosity is around more than 95% porosity. This one is around 60 or 70%. So porosity is.
It seems more porous in picture.
Ah,
Pictorially, it is more porous than the previous one.
I didn't get it.
The picture shows the higher porosity of this as compared to the previous picture.
I don't think so.
PTFE. Maybe your resolution is higher in this case as compared to the previous.
Okay, here. That's the good question. Here, somehow you have to understand. The fiber and fiber are not bonding each other. So it's one on top of the other. So porosity is more than 90%, 95%, something like this. However, this one, that one, the fiber is not like this, stretched. That's why the porosity is lower, a lot lower. But however, that is 1 micron range. So individual this fiber inside is quite small. So, now, track etch membrane. This one, the Father, he mentioned about sometimes making the porous material, put some holes in it and stretch it, but this one doesn't stretch, but actually making holes in it. That's the etch process. So swift heavy ion make the holes on. So the polymeric film like polycarbonate, polyester, pores formed by irradiation or with high energy particles such as heavy ions, followed by chemical etching. The result is membrane with cylindrical pores of controlled size, shape, and density. So the track etch membrane probably porosity might be a lot less. However, the holes are really uniform. Just like that. So holes are really uniform. The pore size is over 10 micrometer to several microns. High pore uniformity, of course. Pore density control from sparse to very dense. High chemical thermal resistance to the material and smooth, good for microscopy and imaging. Certainly, you can look at the SCM pictures. This is, I don't know whether it's a popular process, I doubt it. Polyamide thin film composite membrane using TMC solution and MPD solution and PSF support layer, and then polymerizer occur, and then making thin film composite membrane. Let me see what type of material. TFC membrane. This 30 micrometer still looks good. Here, this is the quite important message. Outside the layer, this is size comparison. The size comparison. So the ultra filtration range is right there. Then probably nanofiltration is down there. But the important thing is reverse osmosis. This one, pore size. Pore size is around 0.005 microns. The salt is around 0.007 microns. So if we like to use the reverse osmosis using some membrane, then the size, micron size, has to be less than 0.007 micron.
Excuse me, I want to raise the volume.
Raise it for? Oh, okay. So this is more likely coming through this one. It has to be something water molecule instead of calcium and natrium, something like that. I told you earlier the red blood cell is about 6 micrometer. It's quite big. So bacteria is about 0.2. So Na ion is going through flow rejected water. It's membrane, something like that. I think it's nothing to do with the RO. Huh? Probably a little bit.
The membrane element is
Shape of membrane filters. Membrane disc, circular, flat membrane, diameter about 13 millimeter, 25 millimeter, 47 millimeter, 90 millimeter. And then they do have a flat sheet membrane, pleated membrane, cylindrical, when inside the cartridge housing, hollow fiber membranes, bundled with the cylindrical. He already showed us. A tubular membrane, straight tube with a membrane lining inside or outside. Spiral wound membrane, fleshed membrane, wrapped around a central tube in a spiral. Capillary membrane, cylindrical, bundle similar to hollow fiber, but typically with a large inner diameter. Here is some examples. Hollow fibers. This is the flat sheet. Yeah, flat sheet is right there as well. The hollow fiber combination. Yeah, plated flat media. We already seen this one. Probably you already see this one. Huh? Spiral membrane modules, 90%. So actually the same membrane is making so-called multilayer, but important thing is permeate side, the mesh spacer. The mesh spacer sometimes control the overall pore size as well. Hollow fiber membrane. Spiral membrane. Started with filtration. It's more likely the deactivate bacteria or viruses membrane. Some membrane does the kill the bacteria or viruses. The UV is really great. UV is really great. So probably they might use the UV similar type. This is the industrial membrane process. I think you already seen something like this. Membrane. Here, membrane module. This is really old picture, but still, some of industry you may be able to see similar to it. So, the membrane properties. What about porosity, pore size, mechanical stretch, thermal, chemical resistance, selectivity, permeability. Last one, comparability. Comparability with the solution that you want to use. So some of the solution may not be appropriate for using certain type of the membrane material. Fouling is a big issue actually. That's why they use the cross flow, generally shear flow. Rotation, vibration are also used to reduce fouling. Certainly, pre-filter is really important. Periodical cleaning is important as well. Now, go. This video is really good one. Really. I really like you to watch maybe twice or more. It's Columbia University made it. Oxford. I'm sorry, Oxford.
The kidneys are organs of the urinary system. They regulate the water content of the body and remove metabolic waste through the formation of urine. How does urine form? When blood reaches the glomerulus, it is maintained at a relatively high pressure. The high blood pressure forces water and small soluble molecules, such as glucose and amino acids in the plasma, through the thin walls of the glomerulus and the Bowman's capsule into the capsular space. This process is called ultrafiltration. The fluid that is filtered into the Bowman's capsule is called glomerular filtrate. The filtrate has a similar composition to plasma. However, no plasma proteins and blood cells are found in the glomerular filtrate because they are too large to pass through the walls of the glomerulus and the Bowman's capsule. After ultrafiltration, the glomerular filtrate flows through the kidney tubule. In the kidney tubule, useful substances in the filtrate are absorbed back into the surrounding capillaries so that they are not lost from the body. This process is called reabsorption. It occurs mainly in the proximal convoluted tubule. In the proximal convoluted tubule, all glucose, amino acids, and most salt are reabsorbed by diffusion and active transport. As many solute molecules are removed from the filtrate, the water potential of the filtrate rises. Therefore, water in the filtrate enters the blood by osmosis. The reabsorption of water raises the concentration of urea in the filtrate. Thus, urea in the filtrate diffuses into the blood. Further reabsorption of substances takes place in the remaining part of the kidney tubule. After reabsorption, the remaining filtrate in the collecting duct is called urine, which will be passed out of the body when we urinate.
Well, why don't you repeat one more? Because this is ultrafiltration inside our body. Go. Once more. Yeah. It's quite important concept.
The kidneys are organs of the urinary system. They regulate the water content of the body and remove metabolic waste through the formation of urine. How does urine form? When blood reaches the glomerulus, it is maintained at a relatively high pressure. The high blood pressure forces water and small soluble molecules, such as glucose and amino acids in the plasma, through the thin walls of the glomerulus and the Bowman's capsule into the capsular space. This process is called ultrafiltration. The fluid that is filtered into the Bowman's capsule is called glomerular filtrate. The filtrate has a similar composition to plasma. However, no plasma proteins and blood cells are found in the glomerular filtrate because they are too large to pass through the walls of the glomerulus and the Bowman's capsule. After ultrafiltration, the glomerular filtrate flows through the kidney tubule. In the kidney tubule, useful substances in the filtrate are absorbed back into the surrounding capillaries so that they are not lost from the body. This process is called reabsorption. It occurs mainly in the proximal convoluted tubule. In the proximal convoluted tubule, all glucose, amino acids, and most salt are reabsorbed by diffusion and active transport. As many solute molecules are removed from the filtrate, the water potential of the filtrate rises. Therefore, water in the filtrate enters the blood by osmosis. The reabsorption of water raises the concentration of urea in the filtrate. Thus, urea in the filtrate diffuses into the blood. Further reabsorption of substances takes place in the remaining part of the kidney tubule. After reabsorption, the remaining filtrate in the collecting duct is called urine, which will be passed out of the body when we urinate.
अगर आपका बच्चा सिर्फ मार्क्स ला रहा है और कॉन्सेंट्रेट
Yeah. Kidney, if somebody has a kidney issue, then in US the same thing. We have to wait a lot. Somebody donate the kidney and then replace it. But scientists, especially Oxford, they are trying to make the man-made kidney using ultrafilter. Oxford. Using man-made ultrafilter material. Exact material is stretched membrane, EPT-free. Yeah, they try several times, but it's currently not successful. However, they try to understand reabsorption. That's the issue. The ultrafiltration-wise, it's okay, but reabsorption is tough. So, I believe maybe about 5 or 10 years later, they might be able to come up with the man-made kidney. So currently there are a bunch of patients who have.
Suppose it is filtration first, then it is absorbed. Why it is done this way? What is the reason? Why it is done in a two steps? For example, you are removing something, then it is reabsorbed. Okay. Why it is done in a two step process? Why it is not done in a single?
Retaining vitamins and minerals of the
See, if you see the filtration, first filtration, glomerulus filtration, that is similar to that ultrafiltration. What happened during the removal of the urea matter is larger in nature. It is larger. So whenever you are removing the larger one, smaller one like glucose, amino acid, that will be also removed. That is the main issue. As because you are removing the larger particle, smaller particle will be also removed. Now how to handle the smaller particle? Then it is reabsorbed. That is why it is second step process. Otherwise, why not single step process? That is the point. And people are also trying to make actual, replica of kidney. Okay, but it is not the membrane way. They are using the 3D, 3D bioprinting and tissue culture. 3D bioprinting and tissue culture. By having this combination, they are trying to develop the kidney in place of your, whatever the dialysis system, present dialysis system. But it will take a lot of time because kidney, the nephron is the unit of kidney. So that is very complex organ. Okay. That is the problem. Nephron is not so easy.
Yeah, like I told you, reabsorption is key issue. So, so somehow they have to come up.
Absorption is basically biological phenomenon. Whereas the ultrafiltration, that is easy to replicate, but the biological one is very difficult. Whichever is biological. Reabsorption is biological. That is the main biology.
Yes, that's why I really want you to look at twice. The reabsorption part is really important part. So, well, normal person they actually miss that. Miss that. Filtration wise, I believe any university research, they can come up with a man-made material. And then, like he's saying that the biologically related, the absorption is so difficult. So I actually searched the ranking of membrane material several places. You know, the future number one is EPTFE. So I'm keep telling everyone somehow somebody need to pay attention to it. Produced EPTFE. Even though you start right now, it takes a time in order to produce a sellable material. Normally it takes 5 years. So start early better. So EPTFE is, first of all, is inert. The other one is the temperature. It go up to 300 degrees. Up to almost melting point of the PTFE is 340, 300 degrees. The other thing is, this one, friction factor is low. So, certainly it's the hydrophobic material, but you can still make it hydrophilic. Somehow you have to use some high voltage, some other things. So this is what I prepare for. Oops. The membrane. So any questions about membrane? Yes.
Sir, I had a question about solution casting technique. How is the thickness controlled?
How what?
How do you control the thickness of the membrane? Uniformity of thickness? Solution casting.
That's as far as the EPTF is concerned, it's just like making bubble. Have you seen the polyethylene bubble process? Huh? The polyethylene bubble process, garbage liner making like this, is making bubble. Bubble and then making. It's more like the same thing. When you look at the EPTFA process, it's kind of bubble. So uniformity side is a little bit thick, but otherwise it's quite uniform all across.
But sir, I was asking about solution casting.
Huh?
Solution casting. There is a method of filmmaking.
Any measurement?
Solution casting method.
Solution casting. Solution casting, I'm not really familiar with that process. However, always uniformity is key issue. That is correct.
And second is maybe the air bubbles trap.
Yes,
Casting.
correct. That is correct. Yes.
I don't know how it is handled in industrial.
Once you process it, there is no way you can handle it. That is issue. I hope any Indian companies or even research institute, they just start making EPTFE. Yeah. To me, I actually asked him to do it, but I don't think he has money to do it.
Currently, usually it is manufactured by Vortex. UK.
You told us that
It is a very big product in water breathable fabrics.
Or is the starting company. Yeah.
Permeable to vapor.
Yes.
there are three companies that manufacture EPTP, right? You told us.
Or is starting company now. The China, I believe there are 3 big companies.
Yeah.
They are making EPTFE currently. Yes. This is really interesting. Three of them, they actually work for me. I can tell you one thing. I don't know if that is okay or not. The Daikin is producing the PTFE powder. So Daikin has some the division who can actually stretch it. So Nitto Denko has big plant, stretch EPTFE. They are cooperating really well, Daikin and them. Daikin, they used to have the stretching equipment, but they still have it. So 3 of them, I'm still counting with them, where actually they have some issues that normally ask big questions. So I know them quite well, so certainly right now I don't have to keep all the secret myself. I just give away. So I do have patent on the PTFE. Yeah, EPTFE. Stretching kind of process. So he's kind of worrying about timing. So next one is quite interesting one. Sustainable material. So is that okay? Stop here and continue on next one. Okay. Do I need